Okay, let's dive right into this explainer. Today, we are playing the examiner's game, and the goal? Well, the goal is to win big and completely master your Cambridge computer science exams. I want you to think of the exam hall as your very own casino royale. The tension is high, the clock is ticking, and the stakes are your final grades. To win, you absolutely need to know when to hold on to your core concepts, when to fold on a really bad line of reasoning, and exactly when to push your chips to the center and go all in on your analytical depth. Specifically today, we're going to crack wide open one of the most notoriously misunderstood areas across the entire board, but especially in Syllabus 9618. I'm talking about SQL DML, inner-join queries from multiple tables. As a strategist and someone who has analyzed these Cambridge exams inside and out, I'm here to tell you that examiners consistently report this specific topic as a massive stumbling block. I mean, students are just constantly leaving marks on the table. But that is not going to be you, not anymore. By the end of this explainer, you are going to walk away with a complete, foolproof system to extract maximum points, conquer absolutely any unfamiliar database scenario they throw at you, and walk out of that exam hall with the exact grade you deserve. So, let's get started.
To truly understand how to win this game, we first need to take a hard look at how people lose. Let's look at two incredibly typical students facing a really complex computer science past paper question. For instance, one of those rigorous, multi-layered database query problems. Okay, on the left side we have Alex. Now Alex is a hard worker. Alex has spent hundreds of hours just brute force memorizing the textbook. But when faced with an inner join question, Alex completely overloads the page with raw computer science facts. They write entire paragraphs about what SQL stands for, they go into the history of relational databases, they give basic definitions, but there is absolutely no analysis. It's just a massive unstructured data dump. They are hoping the examiner just finds something worth a point in there. Then on the right side, we have Sam. Now Sam actually knows the material really well, but Sam completely panics the second that clock starts ticking. Sam rushes, Sam misses the specific command words in the prompt and just frantically throws together a select star query that completely ignores the required table relationships and the crucial on clauses. Both of these students bleed marks, but for entirely different reasons. So why do they struggle so much when applying these concepts to unfamiliar contexts? It's simple, really. It's because they lack a systematic procedural framework. They're essentially playing the game completely blind.
And this brings us to a stark contrast between what candidates actually think examiners want and what examiners absolutely demand. Let's compare the superficial breadth of Alex's data dumps against the analytical depth of a top scholar's highly contextual answer. You see, academic benchmarks in Cambridge computer science, they prioritize deep, structured reasoning over simply throwing every single SQL fact at the page. The assessment objectives for an SQL DML inner join target very distinct cognitive domains. First, you have knowledge and understanding. Second, practical application. And third, critical analysis. Alex is completely stuck on layer 1. The theoretical architecture of an inner join rests on precise definitions and causal relationships. You can't just say, oh, it joins tables. You have to demonstrate a connected, conceptual understanding of how and why it does that. When a top-performing student sees an unfamiliar context on the exam paper, they do not panic. They use analytical depth to identify the primary and foreign keys of the given database, they apply the relevant principles of relational algebra, and they execute their analysis with crystal-clear logical working. That is what gets the marks. And that analytical depth builds right into our strategy by revealing the ultimate cheat sheet. I'm talking about the principal examiner reports. These reports are literally the examiners telling us exactly where candidates bleed marks when querying multiple tables. They are absolute gold. So here are the top 3 examiner warnings you absolutely must memorize. Warning number 1. Answers are often way too vague. Examiners want specific technical details. Don't just write, the query connects the data. No, you need to say the inner join operation combines records from the customer and order tables based on the matching customer ID primary and foreign keys. See the difference? Warning number 2. Students constantly forget to check boundary conditions in edge cases. What actually happens if a foreign key is null? What if there are duplicate records? You have to prove your algorithmic thinking by anticipating these specific scenarios. And warning number 3. Answers are not specific to the context given in the question. Look, if the past paper is about a hospital database, your SQL analysis must specifically reference patients, doctors, and appointments, not just generic placeholder tables like Table A and Table B. You have to live in the world of the question. Before we dive into the pure technical definitions, I need to give you an absolute examiner alert. A total mindset check. Success in your Cambridge examinations requires tuning out distractions and focusing completely on the specific mechanics of the syllabus. It's incredibly easy to just rely on generalized advice, but achieving those top marks requires consistent, dedicated practice and a total commitment to mastering the nuances of the grading rubrics. So, before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. You have to commit to engaging with these frameworks regularly so that you never, ever walk into an exam hall feeling unprepared. All right, let's get technical, because you cannot build a winning strategy on shaky foundations. You should always clearly define your terms before launching into extended evaluations. So, what is an inner join? It is a SQL data manipulation language, or DML, operation that combines records from multiple tables based on related columns. Listen closely. It is not a mere filter. It is an intersection of datasets based on precise relational causality. And this is so crucial because whether you're studying syllabus 0417, 0478, 0983, 0984, 2210, or our main focus today, the advanced 9618 AS and A level, this core principle remains absolutely identical across the board. The syllabus explicitly requires candidates to demonstrate mastery of these fundamental principles. If you start an extended response by establishing this precise definition right out of the gate, you immediately signal to the examiner that you are a top-tier candidate. You show them that you fundamentally understand the theoretical architecture of the subject. So, knowing the definition is great, but how do we actually apply this in the heat of the moment when the clock is ticking down? We use a deconstruct, solve, and evaluate procedural framework that will completely transform your algorithmic thinking. Think of this as your 5-step master plan for absolutely any complex problem they throw at you. Step 1. Identify the given information. What exact tables are we working with? What are the specific primary and foreign keys? Write them down. Step 2. Break the problem into logical steps. Step-by-step decomposition is essential here. Don't try to write the whole query in your head. Step 3. Solve systematically. This is where your practical application comes in, designing the algorithm, establishing the correct on clause, and implementing the SQL syntax efficiently as possible. Step 4. Check for reasonableness. This is where everyone loses marks. Did your inner join just return 3 million rows when you only have 50 customers in the database scenario? If so, that means you missed a boundary condition. Rigorous testing is part of the process. And finally, step 5, make justified recommendations. The higher order assessment objectives demand that you don't just solve the problem, but you evaluate its structure and its efficiency. Now, to execute that 5-step plan in your written answers, instead of giving unstructured, rambling answers like Alex did, top scholars use the PEAL framework. That stands for point, evidence, explanation, and link. This structure ensures your SQL analysis targets knowledge, application, and evaluation perfectly every single time. Let's walk through it. Say the question asks you to evaluate the use of an inner join for a specific multi-table query. Your point, you state clearly that an inner join is the most efficient method to retrieve matching records from both tables. Next, your evidence. You actually write out the specific SQL syntax, such as select patient.name from patient, inner join appointment on patient.id equals appointment.patient.id. Notice how I'm referencing the exact tables provided in the scenario. Then, your explanation. You detail exactly how the database engine matches the foreign key to the primary key, effectively filtering out any unlinked records. And finally, the link. You connect this back to the broader syllabus, perhaps discussing how this supports data integrity or reduces data redundancy. This structured approach absolutely guarantees that every single sentence you write is earning you marks. Consider this a mandatory stop and check moment. Look, in the middle of a high-pressure exam, it is so incredibly easy to just keep writing, just frantically pulling from your mental database of memorized facts without stopping to actually verify your logic. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Taking just 10 seconds to verify our logical framework before moving on to the next question can easily save you 2 to 3 grade boundaries. Don't rush the process. Okay, time for an interactive workshop. Imagine the clock is ticking. You have exactly 60 seconds left in the exam. Let's look really closely at a flawed paragraph from our student Sam and try to spot exactly where the boundary conditions are completely ignored. Read this with me. Sam wrote, "To get the customer orders, I will use an inner join on the customer and order tables. This will combine the tables and output all the data needed for the shop." Okay, did you spot the flaw? Where is the money leaking out of this answer? Well, Sam has identified the tables, which is good, but Sam completely failed to specify the related columns. There is absolutely no mention of the on clause in the SQL syntax. Furthermore, Sam says it will output all the data needed, entirely missing a massive edge case. What about customers who haven't placed an order yet? An inner join inherently excludes them. If the shop actually needs a list of all customers alongside their orders, even the ones with 0 orders, then an inner join might be the totally wrong approach.
Sam rushed, missed the specific context of the shop's needs, and totally lost the critical analysis marks. So, learning from Sam's mistake, the crucial point we need to pivot to right now is mastering the method mark strategy. The principal examiner reports make something incredibly clear, and you really need to hear this. Examiners actually want to award you points. They award points for systematic processing, even if your final syntax isn't perfectly polished. Let me repeat that. If your SQL query is missing a semicolon or you slightly misspell a field name under pressure, you do not necessarily lose all the marks for that question. You are assessed heavily on your algorithmic thinking. Did you extract the right requirements from the scenario? Did you select the appropriate data structures? Did you attempt to implement efficient code? And did you document a strategy to test it rigorously? The method mark strategy dictates that you absolutely must show you're working. Write out your logical steps. Because if you demonstrate the correct procedural framework, the examiner can and will award you substantial method marks, even if your final execution has a minor syntax error. And when you're analyzing alternatives for querying multiple tables, top-scoring candidates always use a very specific technique to justify their trade-offs. It's called comparative analysis. Higher-order assessment objectives demand that you don't just explain one single approach. You have to evaluate alternatives. And to do this effectively, you must identify similarities and differences. Let's say you're comparing an inner join to a nested subquery. You need to use comparative connectives, words like whereas, conversely, or in contrast to. For example, you would write, an inner join directly merges datasets based on a related key, whereas a nested query processes the inner select statement first before passing the results to the outer query. It flows beautifully, right? But you cannot stop there. You must support each of those comparisons with evidence from the given scenario, and then draw justified conclusions about their relative importance, acknowledging any limitations in database performance, execution time, or code readability. That is how you secure an A-star evaluation. Now, this syllabus explicitly emphasizes that referencing cross-topic connections within your SQL answers will help you achieve significantly higher marks. This is the secret sauce that separates the A-grade students from the elite A-star students. On the left side, we see isolated knowledge. That's treating SQL as if it exists in a total vacuum. On the right, we have cross-topic connections. So ask yourself, how does an inner join relate to, say, third normal form? Well, because we normalize databases to reduce data redundancy, we're forced to separate data into multiple discrete tables. Therefore, the inner join is the essential tool required to recombine that normalized data into meaningful user views. Or think about this. How does querying multiple tables relate to data privacy or security? Perhaps by joining tables, you might accidentally expose highly sensitive user data if your query isn't strictly defined. By integrating SQL DML with other crucial syllabus areas, you prove to the examiner beyond a shadow of a doubt that your conceptual understanding is fully connected. We are entering the end game now. Let's lock in the complete success blueprint. These are the 3 definitive rules that will guarantee you extract maximum points on exam day. Applying this system gets you to 100% mark potential. Rule number 1. Command word decoding. If the question specifically says evaluate, you must provide advantages, disadvantages, and a justified conclusion. If it says describe, you just need to state characteristics and features. Never ever rush past the command word like Sam did. Rule number 2, Peel framework application. Point, evidence, explanation, link. Use this exact structure for every single extended response to ensure total analytical depth. And finally, rule number 3, the time management matrix. You must brutally allocate your time based on the marks available. Please do not spend 15 minutes writing out the entire history of SQL for a simple 2-mark definition question, like Alex did. Spend your time with a critical analysis, and the method marks are heavily weighted. Listen, students who actually implement these computer science strategies see an average improvement of 2 full grade boundaries. But that only happens if they practice consistently with our weekly videos. Knowing the theory is one thing. Putting it into action under intense time pressure is completely different. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGSC to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGSC and click that bell. Don't let another exam pass you by. Also, drop a comment below right now with your target grade for computer science and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this video with a study partner, because Ace the Exams is where your Cambridge success starts. Let's leave the casino table today with one final, absolutely crucial thought straight from the Cambridge syllabus itself. Quote, top-performing students exhibit connected conceptual understanding transferable to unfamiliar contexts. Unquote. I want you to ask yourself a really hard question right now.
Are you just memorizing lines of SQL code, hoping and praying that the exact same past paper question shows up again? Or are you truly building a conceptual understanding, mastering the theoretical architecture, the causal relationships, and the step-by-step procedural framework that can conquer absolutely any unfamiliar exam question the examiners decide to throw your way? The stakes are high, but now you have the ultimate strategy to win. Take these insights, practice your past papers strictly using the Peel framework. Always remember to check with tricky edge conditions, and I will see you in our next explainer. Keep learning, stay focused, and keep pushing for that top grade. You've got this.